How does a 3D printer extruder work for robotics projects? Imagine building a robot from scratch and needing custom parts that fit perfectly. That's where a 3D printer extruder becomes a game changer for robotics. It's like having a tiny factory right on your workbench. The extruder is the part of the 3D printer that feeds and melts the material you want to turn into a part. It has a motor, usually a stepper motor, that pushes the filament, the plastic or other material into the hot end. The hot end heats up to a specific temperature, depending on the material. For example, PLA melts around 170 degrees Celsius, while ABS needs about 220 degrees Celsius. Inside the hot end, there's a heating element and a thermistor. The heating element warms the filament, and the thermistor keeps track of the temperature. This precise control stops clogs and makes sure the filament melts evenly. Once melted, the material flows through a tiny nozzle, often just 0.5 to 1 millimeter wide. This nozzle deposits the melted filament onto the build platform in thin layers. There are two common types of extruders used in robotics projects. The first is called a direct drive extruder. Here, the motor is mounted directly on the print head, pushing the filament straight into the hot end. This setup gives you more control, especially with flexible filaments like TPU, which can be tricky to print. The second type is the Bowden extruder. In this design, the motor is mounted away from the hot end, pushing filament through a long, flexible tube called a Bowden tube. This makes the print head lighter, allowing for faster movements and bigger prints. When working on robotics, you might want to print parts with different materials. For example, flexible filament for grips or conductive filament for circuits. The extruder needs to handle these materials well, which means choosing the right extruder design and temperature settings. Some robotic arms have extruders mounted on them, so they can print in multiple directions. This lets you create complex shapes and large parts that traditional printers can't handle. These systems often combine the precision of 3D printing with the versatility of robotic movement. Understanding how the extruder works helps you make better choices when designing or building robotic components. It's the core of turning digital models into real, functional parts. Whether you're making prototypes, custom gears, or entire robotic bodies, the extruder is what brings your ideas to life layer by layer.